In this video, we're going to be looking at the multiplication and division of integers, which are the other two operations of integers. So here we'll look at some models that deal with multiplication and division of integers, some of the properties of integer multiplication, integer division, order of operations on integers, and how to order integers. Okay, let's look at some models that deal with integer multiplication. One of them is the pattern model. Here we want to first find 3 times negative 2 using repeated addition. Here, 3 times negative 2 means that negative 2 is going to be added 3 times. So if you add negative 2 plus negative 2 plus negative 2, you're going to end up with negative 6. Now you can use the community property to find negative 2 times 3. Here, negative 2 times 3 is the same as 3 times negative 2, which is also negative 6. If you recall, the community property means that the order does not change the answer. Now to find the pattern, negative 3 times negative 2, we're going to follow this pattern. 3 times negative 2 will give me negative 6. This first factor is going to decrease by 1. So 2 times negative 2 will give you negative 4. 1 times negative 2 is negative 2. 0 times negative 2 is 0. Negative 1 times negative 2. Notice this gives me positive 2. So when this is decreasing, this is going to increase. Because we're going down from negative 6, then negative 4, negative 2, 0, and then up to 2. So in other words, we're increasing by 2 each time. So that pattern is followed here. And then negative 2 times negative 2 will be 4, and then negative 3 times negative 2 will be 6. A couple of models that can be used in integer multiplication, of course, is the chip model. We talked about that in integer addition and subtraction. The chip model, this says you have 3 groups of 2 red chips. The red chips represent negative 2, negative, and the black chips are positive. So 3 groups of 2 red chips, or 3 times negative 2, would give us negative 6. And the same with the charged field model. 3 groups of 2 negative charges. The negatives are negative 1, so 2 negative charges represent negative 2, and there are 3 groups of them, so 3 times negative 2 will be negative 6. Okay, let's look at the chip model closely. To find negative 3 times negative 2 is equal to 6, you want to start with a value of 0 that includes at least 6 red chips, and then remove the 6 red chips. In this case here, we're starting with 0 here, and then we're putting in 6 0 pairs. 6 black chips and 6 red chips. Okay? Remove the groups of, you're going to remove 3 groups of 2 red chips. That's 3 times negative 2. So here's one group of 2 red chips, a second group of red chips, and a third group of red chips. We're removing those. Once those are gone, you have 6 black chips, or positive 6. That represents negative 3 times negative 2, which is positive 6. Now the charge field model, here you're going to have 6 plus signs and 6 minus signs. That's 6 0 pairs. So again, you'll remove 3 groups of 2 negative charges. So in this case here, here's one group of 2 negative charges, another group of 2 negative charges, and a third group of 2 negative charges. Take those out, you'll have only 6 positive charges. So that's another way of representing negative 3 times negative 2 equaling to negative 6. The number line model is this. You're going to demonstrate multiplication by using a hiker moving along a number line. Traveling to the left or west means moving in the negative direction, and traveling to the right or east means moving in a positive direction. Time in the future is denoted by a positive value, and time in the past is denoted by a negative value. So in this case, to represent 3 times 4, here's the situation. If you are now at 0 and move east at 3 miles per hour, where will you be 4 hours from now? You're moving you're moving to the east at 3 miles per hour 4 hours from now. That's positive 3 times positive 4, which will give you positive 12, which means you will be east of 0. You'll be 12 miles east of 0. Now, if you are now at 0 and moving east at 3 miles per hour, where were you 4 hours ago? 4 hours ago will represent negative 4. Moving east at 3 miles per hour is positive 3. So you were 12 miles west of 0. Another way, if you move west at 3 miles per hour, where will you be 4 hours from now? Moving west at 3 miles per hour, that means 4 hours from now, you'll be at negative 12. So you'll be 12 miles west of 0. And then this fourth case, moving west at 3 miles per hour, where were you 4 hours ago? You'll end up being a positive 12. Because that represents negative 3 times negative 4, which will be positive 12. Okay. Now for any integers a and b, if a is greater than or equal to 0 and b is greater than or equal to 0, or a is less than or equal to 0 and b is less than or equal to 0, then a times b is going to be the absolute value of a times the absolute value of b. In other words, if you're multiplying two integers that have the same sign, pretty much that answer is going to be positive. Okay? In other words, if you have a positive times a positive, that equals to a positive. And then negative times negative is also equal to positive. Because if you multiply two integers that have the same sign, the answer will be positive. And then number 2, if one of a or b is less than 0 while the other is greater than or equal to 0, then a times b is equal to the opposite of the absolute value of a times the absolute value of b. In other words, if you have different signs, if you're multiplying two integers with different signs, it's negative. A positive times a negative will give you a negative, or negative times positive will give you also negative. Okay? So, when you multiply two integers that have the same sign, you'll get a positive answer. If you multiply two integers with different signs, the answer will be negative. Alright? Now let's look at some properties of integer multiplication, which are the same for whole number multiplication. The closure property for multiplication of integers is this. A times b is a unique integer. So here a, b, and c are going to be in the set of integers. So if you multiply two integers, you're going to get a unique integer according to the closure property. Commutative property of multiplication of integers is this. A times b is equal to b times a. The order does not change the answer. Negative 3 times 4 is the same as saying 4 times negative 3. You're still going to get negative 12 either way. The associative property of multiplication of integers means that the grouping does not change the answer. I can group a and b together and multiply those and then get the product of that and c. That's the same as grouping b and c together, multiply it together, whatever that is, multiplied by a. That's the associative property of multiplication. The grouping of the numbers does not change the product. The identity property of multiplication is this. The unique integer in this case is going to be 1, such that for all integers a, 1 times any integer is going to be that integer itself, or an integer times 1 will be that integer itself. The distributive property of multiplication over addition is this. If you have a times, and in parentheses b plus c, we distribute the a over the b and the c through multiplication. A times b will give you ab, and a times c will give you plus ac. And the same thing here. B plus c in parentheses times a means this. B times a plus c times a. And the zero multiplication property of integers, the unique integer is 0 such that for all integers a, 0 times any integer is 0, or any integer times 0 is 0. Okay, more properties of integer multiplication. For all integers a, b, and c, in this case here, negative 1 times a will be negative a. The second one, negative a times b, is the same as b times negative a, which is going to be equal to the opposite of the product of a and b. And then number 3, negative a times negative b would just simply be ab. As we're multiplying two integers with like signs here, so it's going to be positive. And then the distributive property of multiplication over subtraction for integers, the same thing, but the sign would be subtraction. A times b minus a times c. And also b minus c in parentheses times a is the same as saying b times a, then minus c times a. All right, let's look at some examples of how to use the distributive property of multiplication over subtraction. Simplify each of the following so that there are no parentheses in the final answer. Here we got negative 3 times the quantity x minus 2. Okay, so when we use the distributive property, we take the negative 3 multiplied by x, you're going to get negative 3x, minus negative 3 times positive 2, which is this right here. Now, if you multiply negative 3 times negative 2, you're going to get negative 6. So now you have negative 3x minus negative 6. And minus a negative is saying, it's the same as saying plus 6. Subtracting a negative 6 is the same as adding 6. So you'll end up with negative 3x plus 6. Or you can think of this. We know the negative sign is going to change everything in the parentheses to the opposite. So when you multiply negative 3 times x, that's negative 3x. And then negative 3 times the minus 2, that's going to be automatically plus 6, which is what we have here, negative 3x plus 6. Okay, here's another example here. A plus b times a minus b. Okay, now to start this problem off, we're going to look at this here. A plus b times a minus b. What they did here was they took the a plus b and distributed over the a and the minus b through multiplication. So this will be a plus b times a, which is this part right here, then minus a plus b times the b, which is this part right here. Now again, we can use the distributive property if we want to. Here, a times this a on the outside gives me a to the second. B times the a will give me b times a, or ba. Then minus, now notice this is in parentheses, just like this one's also in parentheses. A times this b is going to be ab, plus b times the b would be b to the second. Okay. Now, here we can rewrite this as subtracting ab plus b squared as adding the opposite of ab plus b squared. We just change subtraction to addition and change this expression to the opposite, where you see the negative sign in front of the parentheses. Then next, distribute this negative over these two terms. This negative will make the AB negative AB, which is all in parentheses. The negative will make the plus b squared negative b squared. Now, AB plus negative AB, we're adding a term and the opposite of that term. That gives me 0 here. So we bring down the a squared, then plus, bring down negative b squared. And again, we can simplify that as simply a squared minus b squared. Now, that a squared minus b squared has a special name. That's called the differences of squares formula. Okay? If you recall back in algebra, you basically, if you have the sum and the difference of the same two terms, the quick way of multiplying this would be to take the square of the first term minus the square of the second term. That's where this a squared minus b squared comes from. And we're going to apply that to simplify these two examples here. In part A, you got 4 plus b times 4 minus b. Here we got the sum and the difference of the same two terms. So we squared the first term, so that 4 is going to be squared. Then minus the square of the second term, which is b squared. 4 squared, or 4 times 4, is 16. So you have 16 minus b squared. And that's as far as we can go with that problem. And then part B, negative 4 plus b times negative 4 minus b. Again, we got the sum and the difference of the same two terms. So we square the first term, which is negative 4, minus the square of the second term, which is b. Negative 4 u squared is negative 4 times negative 4, which is 16. And then bring over the minus b squared. So negative 4 plus b times negative 4 minus b will give you 16 minus b squared. Here's another example. Here you're using the differences of squares formula to simplify x plus 3 quantity squared minus x minus 3 quantity squared. Okay. So here we got the square of the first term and the square of the second term. That first term was x plus 3, and then the second term was x minus 3. Okay, because we already got a squared minus b squared. So we want to convert that into a plus b times a minus b. In this case, that's the x plus 3 plus x minus 3 for this first term. Then the second part will be x plus 3 minus x minus 3. The x minus 3 is in the parentheses here. Okay, because we're writing it in this form, a plus b times a minus b. Because you can, if you want to, think of this a as x plus 3 and the b being x minus 3. Now, if we can simplify this, we got x plus x, which is 2x, okay. Now, the way they did this to me is a little bit more complicated, so I'm going to rewrite this a little bit here down at the bottom. If I simplify this right here, x plus x is 2x. And then you got 3 plus a negative 3, that's gone. So here we got the 2x. And then you have this right here. Now for this part, bring over x plus 3. This minus sign will make that x minus x, and the minus sign will make the minus 3 plus 3. And then you can see here these x's cancel. And then if you add 3 plus 3, that's going to give you 6, which is where this 6 comes from. So you have 2x times 6, which is 12x. So the final answer there in simplified form would be 12x. Okay. Let's look at another concept, which is factoring. When the distributive property of multiplication over subtraction is written in reverse order as AB minus AC, which is equal to A, and then in parentheses B minus C, and BA minus CA, it's the same as saying B minus C in parentheses times A, and similarly for addition, the expressions on the right of each equation are in what we call factored form. In other words, the common factor, which is A, has been factored out in this particular example. Because as you can see in each of these terms, the common factor is A. So the A goes on the outside. To get what's on the inside of the parentheses, if you do AB divided by A, you're going to get B, minus AC divided by A, you'll get C. And both the differences of squares formula and the distributive properties of multiplication over addition and subtraction can be used for factoring. In this case here, we want to factor each of the following completely. Here you got x squared minus 9. X squared minus 9, that's the differences of squares, because x squared is a perfect square, 9 is a perfect square. So x squared would just be x squared, but 9 can be written as 3 to the second, because 3 times 3 is 9. And then we apply the fact that a squared minus b squared is equal to a plus b times a minus b. So here this will be x plus 3. The other factor will be x minus 3. So here I'm using this concept of differences of squares and how to factor that. The same holds true for part B. X plus y quantity squared minus z squared. This part is the x plus y. Then the second factor will be the plus c. So you have x plus y plus c for the first factor. The second factor will be x plus y minus z. Now in part C, we're going to have to find the common factor in negative 3x and 5y. As you can see, x is the common factor in both of these terms, so the x will be on the outside. On the inside, you want to find out what the other factor is going to be. So we divide each term by x. Negative 3x divided by x will give you the negative 3. 5xy divided by x will just leave you with 5y. So inside will be negative 3 plus 5y. Keep in mind the common factor will be on the outside of the parentheses. Also 3x minus 6. Here the common factor that's in both 3x and minus 6 is 3. Because 3 is divisible by itself and 6 is divisible by 3, so we use 3 as the common factor. And when you factor something, you always want the greatest common factor that's in both of the terms. So the 3 will be on the outside. What goes inside the parentheses? You do 3x divided by 3, you're going to get x. Minus 6 divided by 3 will be minus 2. So you have 3 parentheses x minus 2 as the expression that's in factored form. And in 5x squared minus 2x squared, the common factor here is x squared. So the x squared will be on the outside. And then 5x squared divided by x squared would just be 5, minus 2x squared divided by x squared will be 2. So inside you have 5 minus 2, which will be 3x squared. In this case here, this is where you have like terms, and sometimes they do use factoring in order for you to combine like terms. All right, next operation we'll look at is integer division. If a and b are any integers, then a divided by b is the unique integer c if it exists such that a is equal to b times c. That's the definition of integer division here, because you're trying to find some unique integer such that b times c would give you the a. And of course, these are the rules for dividing integers. The quotient of two negative integers, if it exists, is a positive integer. And the quotient of a positive and a negative integer, if it exists, is a negative integer. Those rules are the same as if you were multiplying integers, or multiplying two integers. And you can also say here that the quotient of two positive integers, if it exists, is a positive integer as well in this particular statement. And we're going to use that definition, if possible, to evaluate each of the following, like 12 divided by negative 4. In other words, you want to find out negative 4 times some number c, which will give you 12. In this case, it would be negative 3. So here, 12 divided by negative 4 is equal to negative 3. And then part B, negative 12 divided by 4, meaning 4 times some number c would give you negative 12. And that would be negative 3. So negative 12 divided by 4 would give you negative 3. And then negative 12 divided by negative 4 means you want to find what number c multiplied by negative 4 would give you negative 12. And that would have to be positive 3. So negative 12 divided by negative 4 would give you 3. Now negative 12 divided by negative 5 means that c times some number 5, some number times 5 would give you negative 12. Now keep in mind c is an integer, meaning a whole number, positive or negative. Because integers, since there is no integer that exists to satisfy this equation, negative 12 divided by negative 5 is going to be undefined over the set of integers. Now keep in mind, negative 12 divided by 5 would give you some number like 2.4, but negative 2.4 is not a whole number, it's a decimal. Because integers consist of whole numbers that are positive and negative whole numbers and 0 with no decimals in it. So you can see why this is undefined over the set of integers. Now if it was a set of, let's say, rational numbers, then it would be negative 2.4. We'll talk about rational numbers a little bit later in this course. AB divided by B if B is not equal to 0. Okay, well that's simply just going to be A because of the fact that, and another way you could write this is AB over B. And you can see here the B's divide out. And you're just going to be left with A. And the same thing with AB divided by A. I can write it like this and divide out the A's. As long as A is not equal to 0, I'm allowed to do that. And I'll be left with just B. Which means AB divided by A is going to be B. Alright, next is the order of operation on integers. When addition, subtraction, multiplication, division, and exponentiation appear without parentheses, this is what we do. The exponentiation is done first. The multiplication and division is done in order of their appearance from left to right. Finally, addition and subtraction are done in the order of their appearance from left to right. And arithmetic operations inside the parentheses must be done first according to the rules 1 through 3. So this is similar to the phrase, please excuse my dear Aunt Sally, if you recall. Because you first do the parentheses, and then the exponents, or exponentiation. Then you multiply and divide. That's in order from left to right. And then add and subtract in order from left to right. And some examples of just that would be this. Let's say we want to evaluate each of the following. 2 minus 5 times 4 plus 1. Okay, first things first. We see multiplication. So we do that first. 5 times 4, that's going to give us 20. So you're going to have 2 minus 20 plus 1. Now we only have addition and subtraction, but we do the subtraction first because that comes first in the order from left to right. 2 minus 20 is negative 18. Then negative 18 plus 1 will give you negative 17. So the answer to that expression is negative 17. B part. In the parentheses, 2 minus 5 multiplied by 4 plus 1. We got the parentheses here, so we do that first. 2 minus 5 is negative 3. So negative 3 times 4 plus 1. Well, negative 3 times 4 is negative 12. Negative 12 plus 1, negative 11. And then finally, 2 minus 3 times 4 plus 5 times 2 minus 1 plus 5. We see multiplication here and here. We got to do that first. Bring this 2 over. Then do 3 times 4. That's going to be 12. So you got 2 minus 12. And then plus, let's do 5 times 2, which is 10. Bring over the minus 1, then plus 5. And then we're going to go from left to right, because all we have is additions and subtractions. We start with the subtraction first because that appears first. 2 minus 12, that's negative 10. Negative 10 plus this 10 is 0. 0 minus 1 is negative 1. Negative 1 plus 5 would be 4. So the final answer there would be 4. Okay, part D. 2 plus 16 divided by 4 times 2 plus 8. We got multiplication and division, but we do the division first because that appears in the order from left to right. So we bring over the 2 and do 16 divided by 4. That's going to give us 4. Then times 2 plus 8. Now we got to do multiplication. 4 times 2, that's 8. So now you have 2 plus 8 plus 8. This is an all addition problem, so we just add from left to right. 2 plus 8 is 10. 10 plus 8 is 18. All right, part E deals with exponents here. In this case here, negative 3 to the 4th. Now notice the negative 3 is in the parentheses, and that's to the 4th power. So now you're going to have negative 3 times negative 3 times negative 3 times negative 3. Because that exponent of 4 tells me that negative 3 is used as a factor 4 times. So if you multiply negative 3 times negative 3, you're going to get positive 9. Positive 9 times negative 3 will be negative 27. Negative 27 times negative 3 will give you positive 81. So negative 3 in parentheses raised to the 4th power will be 81. But look at F and how it's written. Now you got the negative 3 to the 4th power, but no parentheses. You first do 3 to the 4th power and then take the opposite of that. That's what this means. 3 to the 4th power, of course, is 81, but the negative sign will make the 81 negative. Okay? There is a difference between these two right here. Notice this has parentheses here around the negative 3. This one does not. All right, next we'll look at ordering of integers and the definition of less than for integers. For any integers a and b, A is less than B, which is written like this, A with the less than symbol, and then B, if and only if there exists a positive integer called k, such that A plus k is equal to B. And then A is less than B, or equivalently, B is greater than A, if and only if B minus A is equal to some positive integer. That is, B minus A is greater than 0. And here are some properties of integers. Well, for inequality of integers. If x is less than y and n is any integer, then if you add the same integer to both sides of this inequality, x plus n, it will still be less than y plus n. An example of that, let's say 6 is less than, well, let's say this negative 6 is less than 4. That's true. But let's say I add some integer n, like 2. Negative 6 plus 2 is negative 4. 4 plus 2 is 6. Negative 4 is still less than 6. Okay? So that's what that property number 1 is saying. I can add any integer to both sides of an inequality, and that inequality will still be true. If x is less than y, then the opposite of x is greater than the opposite of y. I'll give you a illustration of that. Let's say I can say negative 6 is less than 4. Take the opposite of negative 6, that's going to be 6. The opposite of the opposite of 4 is negative 4. If you compare 6 to negative 4, you'll see that 6 is greater than negative 4. Okay, so that's basically what this is. The second property is saying. Number 3, if x is less than y and n is greater than 0, meaning n is a positive number, then if you multiply both sides of the inequality by a positive number, that inequality will remain true. This inequality symbol will stay the same. Take that negative 6 is less than 4, multiply it by positive 2 on both sides. Negative 6 times 2 is negative 12. 4 times 2 is 8. You can see negative 12 is less than negative 8. So that's just an illustration of this particular example, property number 3. Now, let's say n was negative. Then the inequality symbol reverses. So here, if I wanted to multiply on both sides of this inequality by negative 2, negative 6 times negative 2 is 12. 4 times negative 2 is negative 8. Here, 12 is greater than negative 8. The inequality symbol reversed. So to put all this in perspective, if you add or subtract on both sides of an inequality, the inequality symbol remains the same. Multiply both sides of an inequality or divide both sides of an inequality by a positive number, the inequality symbol remains the same. But if you multiply or divide on both sides of an inequality by a negative number, the inequality symbol will reverse to the opposite direction. Here's some examples here. Part A, x plus 3 is less than negative 2. We want to get x by itself, we're adding 3, so the opposite of that would be adding negative 3 on both sides. Or subtracting 3 if you want to think of it like that. So here, negative 2 plus negative 3 will be negative 5. So x is less than negative 5. Here we're adding the same, adding some integer to both sides of this inequality, meaning that the inequality symbol stays the same. Okay? Now, negative x minus 3 is less than 5. We want to get negative x by itself, we're subtracting 3, so the opposite would be adding 3 on both sides of this inequality. So that'll leave us with negative x is less than or equal to negative x is less than 8. But using the property number 2, we can take the opposite of negative x, which will be x, but we have to reverse this inequality symbol to the opposite direction, which is going to be greater than negative 8. Or you can think of this. You're dividing both sides by negative 1, which means this inequality symbol will change to greater than. So this will become positive x, and then 8 divided by negative 1 will be negative 8. So you have x is greater than negative 8. And finally, if x is less than or equal to negative 2, find the values of x such that 5 is greater than 3x. Find the values of 5 minus 3x, I'm sorry. So here x is less than or equal to negative 2, which means that negative 3x is greater than or equal to negative 3 times negative 2, which means that negative 3x is greater than or equal to 6. And then you'll have 5 plus negative 3x is greater than 5 plus 6. And that will mean that 5 plus negative 3x is greater than or equal to 11. Which means all the integers in this set will have to be 11, 12, 13, 14, and so on. Because you're finding all the values of 5 minus 3x if x is less than or equal to negative 2. Okay, and that will conclude this particular video on multiplication and division of integers.